Good morning. So my name is Jithin and I am Assistant Professor of Computer Science Department. Now today we will discuss about exception handling in Java. Okay, so an exception is actually a problem which interrupts the normal flow of a Java program. And this exception is a vast topic in Java programming, and as a result of exception, the normal flow of execution of program interrupts, and we need to handle the Java program in such a way that we need to reduce the effect caused by these exceptions. As a result of exception, the normal flow of execution of the program interrupts, and we need to handle the exception in order to make that exception to execute properly, or the effect of that exception need to be reduced, or the program need to be executed in the proper manner. As you know, a program is a set of instructions, and all the instructions in the program need to be executed in a proper manner in order to properly execute the program. But in between, if an exception happens, the normal execution interrupts. There are different possibilities of occurrence of an exception. Say for example, there may be an invalid data that is entered by the user, and also if a file that is opened by the programmer is not opened in the proper way, or that file does not exist, so that is also a cause of generation of exception. And again, if you are executing the program in a computer network and the network connection is lost, then also the exception may generate. So there are different causes for generation of exceptions. There are basically three types or three categories of exception. Two of them are actually exceptions, and the third one is the error which is occurring. And the first one is the checked exceptions, second one is unchecked exceptions, and the third one is error, which is not actually an exception. So these three are the basic issues that are happening while executing a Java program. So first one, checked exception. A checked exception or notified exception is an exception that is generating, or that is coming on the compilation time of a program. So while the compilation time, this checked exception occurs, and we cannot straight away ignore this exception. We need to handle it in a proper manner to execute the program in the proper way. So that's the first type, checked exception. Say for example, if you are going to open a file and that file does not exist in the path in which it is mentioned, so that will create the checked exception. That's the first type of exception. Say for example, I am explaining with an example here. So here we are actually trying to open a file. We are importing the packages, import java.io.file, import java.io.file reader. Then after that, starting the main function, and inside that we have created the file object. Then we are actually opening the file in a particular path, but actually the file does not exist. So if you are executing this program, what happens is that there is no such file which is going to be opened. So this will result in an exception, that is file not found exception. Now we are moving on to the second type of exceptions, that is unchecked exceptions. Unchecked exceptions, unlike the checked exceptions, are those exceptions which are coming on runtime, that is on the execution of the program. These include bugs or logical errors, or we can say that it may be due to the improper use of application programming interface. So unchecked exception is an exception which is happening, as I said before, in the runtime. Here I am explaining it with an example. The example is the exception which is generated in array, that is array index out of bound exception. So here we have actually declared an array of size 5, and we are actually trying to access the sixth element of that array. So what happens is that the size of array is 5, and we are trying to access the sixth element. So this will result in another exception, and that exception is array out of bound exception. So here I have given an example of unchecked exception, that is array out of bound exception. So here I have started the program, the class in Java. Then inside that we have the main function, and an array is declared int num of equals in curly braces 1, 2, 3, 4. That are the elements that is inserted into that array. Then I am trying to print the fifth element, system.out.println num of 5. So here totally we have 5 elements, and I am trying to catch up the element which is not actually there in array. So this will result in an array index out of bound exception, and that exception will be raised. I have talked about two types of exceptions, checked exception and unchecked exception. Now the third one is errors. So errors are different types of situation when compared with exception. That is, errors and exceptions are not actually similar. Errors are not exceptions, and as a result of error, the program will be interrupted or the normal flow will be halted. And actually once an error is coming into our program, then normally even the programmer cannot do anything. So there are different possibilities that an error can creep in the Java program. So errors and exceptions are not similar. Now I am going to explain about exception hierarchy. That is how the different classes of exceptions are arranged in a proper order. In exception hierarchy, we can see the first section, that is all the exception classes are subtypes of java.lang.exception classes. And again, the exception class that we are using is a subclass of throwable class. And again, other than exception classes, there are another subclasses called error, which is actually not an exception, a different type of exception. And again, we can classify or we can place all the classes of exception in the form of a hierarchy. That is, on the top you have the java.lang, then you have the object, then you have the throwable, and the subclass of throwable is errors and exceptions. And the exception has its child class, that is runtime exceptions and other exceptions. So this is the exception hierarchy. Now we are going to discuss about how we can handle an exception. That is, an exception can occur in a program, and we need to handle the exception in the proper manner. That is, if we are handling the exception in the proper manner, then you can execute the program without the error condition or the exception generation. So for that we are using a method, that is the try-catch method, that is handling the exception using try-catch method. That is, all the codes which are prone to generate exception is actually kept inside a block called try block, and those codes which are inside a try block is called protected code. And again, once an exception is generated inside the try block, what happens is that an object is created and that object is thrown. And after generation of an exception in try block, you should have a proper catch block to catch that exception. And the catch block catch that exception object, and it will handle or it will treat that particular exception based on the exception type. So this is actually the exception handling using try-catch statement. As I said, all the exception prone statements should be inside the try block, and you can have any number of catch block after the try block. So based on the type of exception generated, this particular exception object will select which catch block need to be moved to handle that particular exception. So based on the exception type, the catch block type is matched, and that particular catch block handles the exception generated. So that is the exception handling with try-catch blocks. You have an example. You have an array which is declared, and array contains 2 elements, and we are trying to access the third element. So this will generate an exception. So now for exception handling, we have bundled that particular exception prone statement, that is the statement which is going to call the third element. inside the try block. And after try block, we have given the catch statement, because once an exception is generated, an object will be created and that will be thrown, and this thrown exception will need to be caught by the catch block, and it will handle that particular exception. So here we have the catch block, array index out of bound exception space E. So it is actually the parameter which catches the thrown exception object, and it will handle it properly. After that, the catch block will be executed and we will get the system.out.println statement, or the output statement, which is to be printed after the proper catching of exception. So here you will get like array index out of bound exception 3, then out of block, that will be printed as output. Okay, now we are going to discuss about the exception handling in which we are using multiple catch blocks. That is, for a particular try block, we have more than one catch block. And as I said before, we are actually embedding those codes which may generate exception inside the try block. And once an exception is generating, then any type of exception may be generated. So based on the exception which is generated, the catch block need to handle that exception. So for one try block, I can add more than one catch block, and based on the exception which is generated, the catch block will be selected. That is, as I said before, if an exception occurs, an object of the exception will be created and that will be thrown, and this thrown object will be actually caught by the catch block, and this particular catch block will execute, or the catch block which matches its type of exception will actually catch that exception and it will handle it. So that is the multiple catch block, or handling the exception using multiple catch blocks. Here we have one try block, and inside that the protected code or the exception prone code is actually added. Then that is called the protected code, as I said before. Then I have the first catch block which actually catches the exception of type 1, and I have the body part of the first catch block. Then I have the catch block which catches the exception of type 2, and inside that I have the catch block of type 2. Then again I have the catch block of type 3 which handles exceptions which are of type 3. So once an exception is generated inside the try block, then the object that is thrown will check whether the first catch block is matching. If it is matching, then that catch block will handle that exception. If it is not matching, then it moves to the catch block of next catch statement or catch block. Then it will check which catch block is matching its type, and that catch block will be handling, or that catch block alone will be handling that exception. And finally, if no catch block is handling the exception, you have a finally statement which executes the code inside that. So this is actually the exception handling using multiple catch blocks. Examples. Okay, so here I have an example. Inside that, the exception prone code that need to be handled is embedded inside the try block. And inside the try block, or after the try block, I have the catch block. So catch block for one type of exception, that is input output exception, that is IO exception. Then I have the parameter for the IO exception. So that is one catch block. Then again I have another catch block for file not found exception. For that also I have created a parameter, and I have the catch block. Okay, so once an exception is generated, based on the type of exception generated, it will select which catch block need to execute that exception. So here you can see that first catch block is IO exception catch block, second catch block is file not found exception, and even we can actually concatenate the catch blocks, or we can actually add the catch block types, or we can create the parameter for processing which has both the capabilities of two types of exception generated. So that is what is given here. So either type of exception, if it is thrown, it can be caught by a single catch block. So this is actually another type in which we can add the catch block. So normally what we are doing is that for a particular try block, we can have many number of catch blocks, and based on the type of exception which is generated, it will decide which catch block need to handle the exception. Or we can combine the catch block like this. Okay, so these are types of handling with multiple catch blocks. Then I am going to discuss about finally block. So as I said before, the code or the program instructions which are to be embedded or which are error or this exception prone are embedded inside the try block, and we can have any number of catch blocks after the try block, and after all the catch block we can add the finally block. So here there is an example with the finally block. You have the class exception test, then you have the main function, then an array is created, int a of equals new int of 2. Then again inside the try block where the exception prone statement is adding, or I am going to add the statement which may generate exception in future. So system.out.println access element 3. I am going to access the third element. Actually the array has only the size up to 2. Then I have the catch statement, that is array index out of bound exception. So I have the catch statement, array index out of bound exception, then the parameter e. Then inside the catch statement system.out.println exception thrown, that is printed. Okay, exception thrown and the object passed will be printed. Then I have the finally statement. Inside that the a of 0, that is the first element of array, is assigned to 6. Then system.out.println first element value, that is a of 0, will be printed. Then again system.out.println the finally statement is executed, or that particular statement will be printed. So this is an example which contains the finally block. So here you can see the output, that is exception thrown will be printed, that is the catch statement output statement will be printed. Then you can see the array index out of bound exception 3, then first element value that will be given or printed as 6, then finally statement that will be also be printed. Okay, that is the first element value 6 and the finally statement is executed. These two elements in the finally statement will be also printed. Now we are going to discuss about some important points about exception handling. We can say that some key points that need to be remembered while handling with these exceptions. Okay, the first one is that a catch clause cannot exist without a try statement. That means a catch clause cannot be added in the program without a try statement. That is, the exception that is generated from a try statement is caught by the catch statement. So it cannot be implemented as standalone. Then next one is that it is not compulsory to have finally clauses whenever a try catch block is present. That is, it is not mandatory that we need to add the finally clause if we have the proper try catch statements. Then the try block cannot be present without either catch clause or finally clause. That is, without a catch clause or finally clause, we cannot add a try block alone. That means try block is actually used to handle the exceptions. So without the catch block or finally block, we cannot add the try block. Then the fourth point, that is, any code cannot be present in between try, catch or finally blocks. That means we are using the try, catch or finally blocks for exception handling. So no other codes cannot be added in between, because if we have the sequence of execution of exception handling statements, that is try, catch or finally, we cannot add other types of instruction in between these statements. So it should be given in a particular sequencing order. Okay, so that is all about this exception for today. Now, as I said before, as a result of exception, the normal execution of a program will be disrupted and it will be altered. So we need to handle an exception in a proper manner in order to handle the exception, or in order to make or run the program in a successful manner. And again, as I said about exceptions, we have try catch statements that is used to handle the exceptions. And also, without a try block, we cannot use the catch block. And also, we cannot use a try block without the catch or finally blocks. And again, it is not mandatory that we need to use the finally block. So these are some points that you need to remember while handling with exceptions. And also, all the codes that are prone to exceptions are actually embedded within the try block. And once an exception is generated, an object of the exception will be created and it will be thrown. And that object will be caught by the following catch blocks, which is matching with that particular object. And that catch block alone will handle the exception. This is an overview of the exception handling in Java programming. Thank you.